Okay, so again, this is on-site treatment, and this is the first option we looked at in the last one is we're going to take all of our bad water from the building, we're going to send it to the city sewers, and then it's going to be sent off to the water treatment plant down the road, outside of city, wherever it is. Our other option is to do it on site, right on our property that we own. And this kind of system, it collects, treats, and dispenses the water, just like the wastewater plant. And this is used often in rural areas when there's no, wastewater offered by the county or whatever. Rural areas, like out in farm country, is where you're going to see this around here. 25% of single residents in the U.S. use this. So a quarter of the residents, houses, use this in this country, and 33% of new development use it. This is basically the greener option. We think about this as being I think about this as being the old-fashioned kind of way to do it, but it really is the greener way to do it. And as we want to go to being more environmentally sound, we really want to go to the greener way. So it's called a septic system, and then we can call it, that's kind of the old-fashioned name, septic system. Private sewer system, individual sewer treatment system, these are kind of the newer way we might describe them to encourage people to use this environmentally friendly process. Here's a map showing where they're really used a lot. They're really used in the ones that are red up here. And if you think about these states, these are more rural states. Up here in Maine, Vermont, these are not super populated. Over here, South Carolina, Virginia, Kentucky, Louisiana, Alabama, these are much less, much more rural areas. And then the green one, or the yellow ones, are the ones where it's used 26 to 40% of the time. So about a quarter of the time to the 40% mark. And again, you'll notice that these are very sparsely populated areas where there's not a lot of dense population. And then the ones where they use this the fewest is your really more dense, bigger cities, California, Texas, New York, Massachusetts. These are where we are using it the least. But if we think about it, this is kind of the new greener option too. So we really should be, as architects and civil engineers, thinking about pushing people toward using the more environmentally friendly methods. So how does it work? Well, first let's talk about some problems. The problems and the reason people moved away from using this is that the system can fail. And if the system fails, you get the bad water ends up seeping up through the ground. You can see this does not look friendly. Where this little girl is, this is a big puddle of wastewater that's come back up to the ground. And about 10 to 30% of the systems fail every year, and at least 10% of the systems are over 30 years old. This is the problem. The systems that are out there are very, very old. They're over 30 years old, and people don't take care of them the way they should. So that's why we have systems failing. Basically, the systems are really old and they need to be upgraded, replaced, and recycled. When you're putting one in, you need to put it in the right place. It needs to be installed properly, a good design, and you have to keep it cleaned out and keep it maintained. It's kind of like if you think about your air conditioner in your house. If you don't take care of the air conditioner in your house, it's going to go out. The same thing happens with septic systems. So basically this is how it works. The pipe comes out of your house and goes to this big tank. It's a big box underground. And in there, the water gets treated, and then the water comes out after it's treated. It's now got all the bad stuff out of it, and it's now basically gray water coming out. It's not drinkable at this point, but it can be used for, watering grass or whatever. And it's now clean water to come out. And then they have an area where it could be drained to. This out here is like a field, a lawn, something out there where you can put the water. And the water eventually goes down back into the groundwater. Inside that big tank, this is what it looks like. There's a sludge layer. This is heavy particles settle down. This part down here looks like really gross mud at the bottom. Then there's a scum layer at the top. I know, it doesn't sound very attractive, But that's where the grease and the oil that comes out of cooking and stuff comes up and floats at the top and creates a layer at the top. And then anaerobic decomposition breaks down some solids. So this is a microorganism that are going to break down some solids. But the tank has to get this sludge layer and this scum layer pumped out regularly. It's a guy that comes in a truck and they put the pipe down in the hole and they clean this out. This is what the tanks actually look like when they're being put in. So again, this is what I was talking about. Here's that big tank. There's a little distribution box that just distributes the water out to our drain field. And then we have aerobic soil. So this is where the water's coming down and more microorganisms and just the dirt are finishing this. Groundwater's down here, and all this water eventually goes back into the groundwater. If you're going to put in a septic system, you have to, there are tests that you have to do to make sure that your ground is going to work, because your ground has to be such that the water can come through it. We did some information on soils before, and we talked about plasticity and liquid limits. You have to have the right kind of soil here for this to work. That's this first one. You have to check with codes. They do a percolator test, which means, will the water go down? They dig a little hole, put water in it. They fill it with water, and then they measure how fast the water goes down. And the length of the drain field, based on how quickly the water will go down, depends on how big of an area you need for that water to filter down. Here's some reasons it fails. The soil wasn't good to begin with. The water table is really high. You didn't put in a proper, and all of these are you just didn't put it in right. It was too small, it wasn't built good, or you didn't maintain it good. Here's a picture of that truck that literally just cleans these out. Okay, that's it for wastewater.